Hello everyone. So today we will talk about the differences between the points of discontinuity and vertical asymptotes. So before we look at any equations, I want to show you what they look like on the graph and what is their behavior. So let's look at this graph, and we do have a point of discontinuity over here at x equals 1. So what will I see if I look at this point? So here I'm tracing it out, and you can see that I get an empty dot. So what does this empty dot mean? Well, this means that at this point, my function does not exist. So at this point, there is no function, it's a gap. So this is literally just a gap in the function, nothing more to it. I want you to notice a little something. Just because I have a gap right over here doesn't mean that the rest of my function changes. The function comes as close as it can to this gap, then it literally jumps over and continues on as if nothing happened. So another word for this is a hole in the domain, because it means that there is one x value that I cannot have, but it does not affect my function at all. So to do a little recap, right? I have a gap in my function, and it does not affect the rest of my function whatsoever. So the next question is, well, how do we find it using our formula? And this is very, very straightforward. You're going to look for the same linear expression on the top and on the bottom. So you can see that on the bottom over here I have x minus 1, and on the top I have also x minus 1. So I can theoretically cancel those out, but I don't really want to right now, not for point of discontinuity. But they are the things that cancel out. So you have the one in the numerator, the one in the denominator. This is your dead giveaway. Hey, this is a point of discontinuity. So what are you going to do? You're going to set this expression equal to 0, and you're going to solve it. And this is x equals 1. So at x equals 1, I have my point of discontinuity. You can see it very, very, very clearly. Awesome. So this is how you find your point of discontinuity. So what about some other stuff, like a vertical asymptote? What's the difference? Well, if you look at my graph, you will notice that my graph has a wall. And let me show you what I mean. Take a look at this graph. This end of the graph and this end of the graph, it looks like they are trying to cross some kind of point over here, but it's as if they ran into the wall and they keep on moving, trying to find a gap into this wall to get to the other side, but they can't find it. So they get as close to the wall as they can, but they can't cross it because the wall is infinitely long. That wall is your vertical asymptote. So let's go ahead and find it. So when you look at my graph, at the equation of my graph, you will see that I had two expressions in the denominator. I had one that gave me a point of discontinuity, the one that had a matching expression in the numerator, and there is the other one. So this other expression right here, this one gives me vertical asymptote. Now, how do I know it's a vertical asymptote and not a point of discontinuity? If you look, it does not have a matching expression in the numerator. It's just a linear expression in the denominator. So all I'm going to do is set it equal to 0. And in this particular case, I'm going to get 3x equals 2, x equals 2/3. I get x equal to 2/3. Now, x equal to 2/3 in this particular case is not a point. It's a line. Because I told you, it's as if my function is trying to run into a giant wall. So here's my wall, and I'm gonna, somehow it's red, I don't like that, but you can see. So here's my wall, and you can see that it's very different from my function, right? My function is trying to get very, very close to it, but it never quite crosses it. Because this wall is infinitely long, it is impossible to cross. So this is the difference between the vertical asymptote, which is what this wall is, right, and the point of discontinuity. And the difference is the vertical asymptote radically changes the behavior of the function. So here's a little recap. Vertical asymptote is another gap in the domain, right? It's an x value removed from the domain. But unlike the point of discontinuity, it actually changes the behavior of the function, and it changes it quite radically. So if you want to think about it, a point of discontinuity is really just a point. It's a point taken out of the function. A vertical asymptote is a literal line, a giant wall that splits your function in two. And that's it.